All right, we're going to continue on talking about circles, and today we're going to look at segment relationships in circles. Um, and so we've already looked at angle relationships. We looked at those on Wednesday. Um, I think generally speaking, the segment relationships are a little bit easier for kids. Um, but again, what I've done is I've tried to make it as simple as possible, and I've told you what pictures you're going to look for, and we're going to give ourselves a general setup that we need to follow for every problem. Okay. And all these problems today, they're going to be just equations. It's kind of hard to do just numeric examples for these. So everything's going to be an equation today. And so let's get started. So there's two things that could happen. You could have the segments could all be completely inside the circle. So we're going to look at those first, and then you can have the segments meet outside the circle. And so those are different kinds of problems. Okay. And so we'll start with inside, and the picture you're going to look for is something like this. I kind of call these like Easter eggs, like I don't know, because they're like a dot egg or something. I don't know. Anyway, you're going to have two chords that intersect inside the circle, and so let's just say like here I've got this blue one, and then I've got this red one. And so because these chords intersect inside the circle, um, these links are related to each other. And so we would say that I start with one segment and then you multiply the parts that are on it. So A times B equals, then you do the pieces of the red. So C times D. All right, and if you're following, like if you want to say a general form, whatever. So these two pieces are both on the blue. So you would say a blue piece times the other blue piece equal. Then we'll say the two red pieces multiplied together. Okay, it's very simple. If you want to follow the color coding like I did, or just follow the line, and whichever pieces are on that line, they are multiplied together, like we've got here. So let's look at some examples. So down here we've got two chords intersecting. One chord is marked with pieces that are 10 and 9. The other chord is marked with 6 and x. We have to solve for x. And so we're simply going to follow this. I started with the 10 and the 9. So 10 and 9 are on the same one. So the 10 and the 9 are multiplied together. That's going to equal the other chord, 6 times x, or just 6x. Okay, then we'll multiply that together. And then we'll divide by 6 so that x is going to be 15. Okay, that's an easy example. Now, of course, we can get a little bit more complicated. So let's look at this one. If I want to start with the 6, it is this piece of the chord, so I got to travel down to see what's beneath it. That's the x plus 14. So if you want to think about it, you can kind of circle who goes together if you don't want to color code. So 6 will be multiplied with all the x plus 14, and then it'll equal, so we'll come back to the 7, is going to be multiplied with the x plus 12. So 7 times x plus 12. And then we kind of have to distribute twice, so that's okay. So distribute. 6 times 14 is 84 equals 7x. Okay, so we'll subtract the smaller variable. And then we subtract the number. So then we get this. Remember, that is perfectly fine. The variable itself can be 0. It could even be negative. Because remember, the variable is not the actual length of the segment. It helps you get to the actual length. Okay, so don't freak out if x is 0. That's fine. All right. So that was when they're inside. Now we're going to look at when they're outside the circle. Okay, so we have two different cases to look at today. And for outside, there's two pictures we're going to focus on. Sorry, two pictures. So notice we have this outside piece and an inside piece. And then you could look at the whole thing. So I'm going to color all this one color. And then all of that segment another color. Okay. So this one's a little different. I'm actually going to write the colors first. So you start with the outside piece. So this would be the blue outside, so that would be A, times the whole segment. So that would be A and B together on the blue. Okay, now I'll fill that in a minute. And then the same thing for the other segment. It's the red outside times the whole red segment. And so the blue outside is A times the whole is A and B together. So I actually have to add them together. And then it'll equal C times C plus D. Okay, so this one's a little bit stranger. It's not outside times inside, it's outside times the whole. So on the whole, you have to add the outside piece and the inside piece together. That's how we're getting this. Okay? And notice that was the case when you had two secants intersecting. You could have a secant and a tangent intersect outside the circle. So that would look a little different. So on this guy, we only have the outside to deal with. And then on the other one, we have an outside piece and an inside piece. So when you have this, it's a little different. The one that's just outside, we kind of have to follow this model that the outside is multiplied by the whole. Well, down here, the outside is the whole thing. So we just go ahead and say it's the outside squared, or times himself. And that will equal. And then the green is just like up before. The outside times the whole. So outside squared, that would be A squared equals, and then outside green is B times the whole green would be B plus C. Okay, so outsides can be a little different. They're going to be set up like this. All right, so let's look at some of that. Okay, so we've got this is a 2-secant example. We've got a piece of it is the outside piece is 5 and the inside is X. So I'm going to start there. So remember, it's outside times, so it's the outside, then it's the whole thing. It's X and 5. So I'm going to write that as X plus 5. If you want to do 5 plus X, that's fine. I just like to have the X come first. That's just a personal choice of mine. That will equal, same for the other side. The outside piece is 6 times Now I have to do the whole thing. So notice it's going to have a 6 and an x minus 3. I like to start with the x. So x minus 3, my inside plus the outside. So this entire thing right here represents the whole length of that secant. Okay? So now I'm going to clean this up a little. And I'm basically just combining there because I like everything to be as simple as possible before I do any distributing. Now we'll distribute, so 5x, let me show you, 5x plus 25 equals 6x plus 18. Move the smaller variable, so 25 equals x plus 18. Then we'll subtract 18, and then x should equal 7. Let me check if that works. 5 times 5 plus 7 equals 60. 6 times 6 plus 7 minus 3. Yep, okay. Just making sure what I had worked. Okay, so same thing. I'm going to start here with 8. So 8 is outside. Now I got to figure out the entire length. So it's going to be the x plus 6 plus the 8, all added together. So I'm going to write that. Same with the other side. 7 x plus 9 plus 7. I'm going to clean it up. Then we will distribute. 8 times 14 is 112. Then 7 times 16 is also 112. So now we'll move the smaller variable. So x plus 112 equals 112. And at this point, think to yourself, what's the only number you can add to 112 and get itself back? 0. So here, x is 0. Another one of those weird cases. Okay, these two are where you have a tangent and a secant, and so remember the tangent part that's just outside, you'll have to square. So 12 squared equals 9 times x plus 9. So this side is what we've been doing already. This is where you have, instead of outside times the whole thing, you do the outside twice. That's why it's squared. That's 144 equal. I'm going to go ahead and distribute this. 9x plus 81. Subtract 81. And then 63 equals 9x divided by 9. X is 7. That's fine. They're both 7. Anyway. And then similarly, 6 squared equals the 4 outside times the whole length of x plus 4. Square that equals, distribute 4x plus 16. Now we'll subtract 16. So 20 equals 4x. And then you get x is 5, or 5 equals x. Okay, those are segment relationships in a circle. I think you should find these easier than angles. I hope you do. Anyway, that's all I have, so make sure we watch the video all the way through. We complete the homework assignment. And as always, if you have questions, let me know.